Okay, so continuing in Chapter 3 on inequalities, this is Section 2, Part 1, and we'll be using a sign analysis to determine the solution of polynomial inequalities. So the objective of all of Section 2 is to solve and graph polynomial inequalities in one variable, but again, Part 1 is just focused on using a sign analysis. And with this method, we'll be given some sort of polynomial either in this form where we'll have to factor it, or sometimes it's already factored for us. And the usual process is 1, finding the roots or the zeros, then 2, plotting them on a graph, 3, doing our sign analysis just like we did in Chapter 2, and then from there we'll be able to determine our solutions. Okay. So example 1, solve the following polynomial using a sign analysis. Okay. So this one is not factored for us, but notice that there is an x in common in each term. So we can factor that x out. And notice, we can continue to factor this, and it's a pretty simple one. So two numbers that multiply to be -3 and add to be -2 is x minus 3 and x plus 1. So that means our roots here are 0, +3, and -1. Okay, so we can plot those on our graph. Then notice this is strictly less than 0, so that means we'll have to have an open circle at each of our zeros. Then we can do our sign analysis. So if we test one value to the left of -1, let's test -2. Okay, so -2 in for x is a negative, -2 minus 3 is negative, and -2 plus 1 is negative. 3 negatives will be a negative. Then remember from Chapter 2 that when we have a single root, our signs are going to alternate. If we have a double root, the signs will stay the same between that double root. In this example, we don't have any double roots because this x isn't squared or neither of these factors are squared. So all of our roots are single roots. That means our signs are going to alternate. So if we started with a negative, we'll have a plus, minus, and a plus. So now to find our solutions, we're looking for values that are less than 0. Okay, so less than 0 here means that they're going to be negative. We have two sections that are negative. So the zone here is to the numbers that are less than -1. So to the left of -1 is -2, -3, and those are all less than -1. So one solution is x less than -1. Then solutions that are between 0 and 3. Notice that I'm using a less than sign, not less than or equal to, because we're not including 0 and 3, so they're not equal to. So our two solutions are x between 0 and 3 and x less than -1. Okay, so in example 2, we're same thing, solve using a sign analysis. This is somewhat factored for us, but we need to continue to factor this so that we can find our zeros. So we could rewrite this as x squared plus 0x minus 1. That means we need two values that multiply to be a -1 and add to be 0. So it's going to be x plus 1 and x minus 1. Then we can just expand this here because that's doubled. So it's always good to note when you have a double. So x equals 4 is a double root. So remember the signs will have to stay the same on each side of that 4. And our other roots are x equals -1 and x equals +1. So now we'll just plot these. So -1, +1, and 4. This is equal to, so that means these will be closed circles on each of our roots. Now we can test one value to the left of -1, so we can try -2. -2 plus 1 is negative. -2 minus 1 is negative. -2 minus 4, negative, and that's a double, so it's 2 negatives. 4 negatives is a positive, so we'll have a plus here. And again, our 1 is just a single root, so that means it alternates. Then we will continue to alternate, but now the 4 is our double root, so the sign has to stay the same on each side of where our 4 is. Okay. Now again, you could absolutely test one number in between each zone if you're not sure, or to double check your work. Okay, but if you know the rules that if it's a single root it alternates, or if it's a double it has to stay the same, then you can absolutely use that shortcut. Okay? Okay, so lastly, we'll use our sign graph to find our solutions, and we're looking for solutions that are greater than or equal to 0. So looking at our sign graph, zones that are greater than or equal to 0 are going to be positive values. So our solutions are values that are less than -1, less than or equal to, in this case, -1, and then values to the right of 1. Notice because they're both positive, it's all of the values greater than 1. Greater than or equal to 1. So these are our two solutions. Okay, so this was part 1, using sign analysis to determine solutions of polynomial inequalities. Tomorrow we'll go over at least one more example. Hopefully this all makes sense. Have a good night. See you all tomorrow.